Hey gang, back again with you to do section 4.8. Hopefully you're staying strong out there. I know section 4.5 and section 4.7, might have seemed like a couple of doozies to some of you, but hopefully you're making use of the office hours, and that you can kind of go back and watch the videos again, or at least parts of the videos again. But again, don't be shy about dropping into office hours, okay? I think, well, first, I hope you've got at least a decent grip on 4-7, and solving the quadratic equations, possibly even with with the quadratic formula. 4.5 was just factoring. No, wait, no, it wasn't. It was solving using factoring. I tell a lie. Sorry about that. I almost forgot that we dealt with factoring even before. So 4.5 was now. It wasn't just about factoring. It was factoring so that we can solve an equation. You don't just factor. You factor and then you actually get the solutions, using the factoring. And then 4.7 was the quadratic formula, because that's like a backup plan, or it's a. Anyway, let's get in 4.8. I think you're gonna like how much I am going to trim out of here, and I might even, I guess I'll decide when the time comes, but I don't know if this is going to be like the third section in the week, or maybe I'll try to save the due date until like the following week. I don't know, I guess you'll see. But 4-8 is called complex numbers. It will build pretty nicely from what we've been doing. Again, the order you do all these sections in is very, very, very crucial, because it all builds off of each other. So here we go. Oh, look at this really tough question to start off. What is the square root of 9? Well, the square root of 9, that's a pretty nice answer. It's just 3. It's a very clean answer. Square root of 9 is just 3. The reason it's a clean answer is because 9 is a perfect square. Perfect square. What are some others? We've been hitting on that, a little bit, almost like indirectly, as we've done recent lessons. What are some other perfect squares? What are some other numbers you can take like a nice perfect square root? Well, I'll just kind of list them kind of in order. 1 is a perfect square. 4 would be the next one, followed by 9. So those are the first 3 perfect squares. The next biggest perfect square would be whatever 4 squared is. So 16, and then 25, and then 36, and then 49, and then it kind of, basically keeps going forever. But here we go. Enough of the little intro. Let's get down to brass tacks. The reason we're all here right now, participating in this video, is a question like this. What is the square root of -9? Remember how, like, last lesson, 4.7, I mentioned how something like, I don't remember my exact quote, but it was like, we basically can't do that. Taking the square root of a negative number doesn't make any sense. What number times itself equals -9? There is no such real number. You can't say, is it -3? Right? I'll even write that down. Negative 3, I'm Ron Burgundy. No, because negative 3 times negative 3 is positive 9. So, again, it doesn't make any sense. We can't do it. Or can we? Right? Basically, let me just kind of cut to the chase, I guess. I don't want to be so mysterious. Somewhere back in the day, some mathematician or group of mathematicians decided they could come up with like a loophole, and we can somehow create like this entire new set of numbers called the imaginary numbers. Just like all my friends back when I was a kid. There was imaginary numbers, not real. Not real. So there's every number you've worked with up until now, whether it's been rational, an integer, whole numbers, irrational numbers like pi, at least they've all been real, okay? Now, when we start talking about the square roots of negative numbers, it's not even real anymore. It's imaginary. And so here's what I'm going to skip some of this stuff, but square root of anything there. So check this out. We kind of have this number that someone back in the day decided we're going to call this number I, and we're going to say that I is equal to the square root of negative 1. We can't really take the square root of negative 1, but we're going to find a little loophole and just call it I. I obviously stands for imaginary. So using that letter for the variable, it's not really a variable, but it makes sense to use that letter, to say like the imaginary number. All right, so just some little property here. The square root of negative a. If a is any real number, then we say that the square root of negative a is I times the square root of a. So here's what kind of just happened there. So as an example, what if I wanted you to do the square root of negative 6? What is the square root of negative 6? Well, technically, what we do first is we kind of break it up into the square root of negative 1 times the square root of 6. Square roots work that way. We're allowed to break it up like that. And so we kind of break off the negative 1 because the square root of negative 1 is I. Like, by our own definitions, we decided that the square root of negative 1 we're just going to call I, and then the square root of 6, and that's all you really do. You kind of break off the negative, you know what I mean? So you can like bring an I out, you can like bring it out and it becomes an I, you know what I mean? Because the square root of negative 1 is literally I, we're calling. Another example, how about like the square root of negative 4? When you break off the negative, that's going to become I. And what's left is the square root of 4. Now the square root of 4, that's actually nice. That's just 2. So this answer is 2I. And that's how you should say it. You shouldn't say I2. I know I don't want to like dwell a lot on details like this, but here you'd say it as 2I and not like I2. And like here you'd say this as I times the square root of 6 and not the square root of 6I. Again, I don't want to go into detail there and open up that can of worms. Just kind of go with it, please. But anyway, imaginary numbers. So up here, what's the square root of negative 9? It's actually 3I. So simplify the square root of negative 8. Well, first of all, we're definitely going to break off the negative 1, okay? Because that's the only way we're going to be able to do this. We're going to, it's imaginary, you know, and we're going to have to, at the very least, break off the negative 1 so it becomes an I. But, so this becomes an I, basically. But you got to remember that the square root of 8, it's not like the square root of 6. It's not like the square root of 11. The square root of 8 actually can be simplified. It actually has a, wait for it, perfect square that you can break off of it and actually take the square root of it. So I'm going to break off a 4 because I want to take the square root of whatever I can. So I times 2, because the square root of 4 is just 2, and this square root of 2, I can't really do anything else, you know, so it just stays that. So that was like a quick review on simplifying square roots. Now, once again, like I was saying up here, I don't want to get too much into semantics here, but I2 square root of 2, the more proper way to say it is first I put the 2, then the I, then the square root of 2. That would be like proper manners. So, but yeah, that's all there is to it. So far, the only like big idea here is learning how we now have officially this new set of numbers we call imaginary numbers, and it's all based on the fact that someone a long time ago decided to just say, what's this, the square root of negative 1? Let's just call it I. Let's just say it's I. And it's imaginary, you know, blah. All right, definition, complex numbers. Skipped. Next page. Write the complex number, negative, skip. Find the additive inverse, skip. Simplify the expression, skip. Over here on the right side, and skip. Absolute value, skip. Keep it up, Mr. Falk, right? Yeah, keep it up. These next examples. Okay, listen. Skip, but, okay, we are going to skip these. I don't care. I'm picking my battles, right? I told you, meat and potatoes, meat and potatoes. So we are going to skip these, but I do want you to write down one little thing. Okay? Well, then we might as well just do this really, really simple example, basically. 5i times negative 4i. It's going to probably, well, it will. It's going to work out probably exactly how you might think. 5 times negative 4 is negative 20, and then I times I is I squared. Okay? And the only thing I want to at least introduce to you, all right, please pay attention, is that I squared can be worked with. Like it can be simplified. Because remember what I is. Since I is defined as the square root of negative 1, if you square that, I squared, it's going to literally equal negative 1. Just let that sink in for a second. If I is equal to that, then wouldn't it make sense that I squared is just negative 1? Because whenever, like what if you multiplied a square root times itself? Right? Anyway, don't overthink it too much, because again, overall, as far as like, you know, what I'm requiring of you this fourth quarter and stuff, we're skipping this stuff. Okay? We're not gonna skip this though. Okay? This is absolutely now like us referring back to section 4.5, section 4.7, because now we're back to solving. All right? Now, and I'm thinking about the big picture here. You know, if on a test you just saw like a random quadratic equation, what's the first strategy you would use? You know, you might, for example, you might try to get x by itself here, you know, which we kind of can. This actually is the type of example that we can get x, just get x by itself, you know, thinking back to like how you were groomed since like 6th grade or 7th grade or something, or, you know, maybe 8th grade. I'll say 7th grade, whatever, who cares. But all the way back to like 7th grade, you've been groomed to just get x by itself. Here, you actually kind of can, right? You know what I mean? And then what would you do? You would get that 4 out of there, and so you would divide both sides by 4. And so you'd end up with like x squared equals negative 25. What would happen next on your quest to solve for x? You would take the square root of both sides, you know, and that gets x all by itself. And then over here, what is the square root of negative 25? Well, until this lesson, you would have been completely stumped. You would have maybe even grabbed your calculator, plugged in the square root of negative 25, and you know what your calculator would tell you? Like domain error or something. Your calculator isn't programmed, or it's not smart enough to do the square root of negative 25. But we now know, hopefully, or at least you're getting to that point, we now know that the square root of negative 25, especially once you break the negative off, and it's going to be I, the square root of 25 is 5. And so it's going to be 5i. But remember, whenever you do this kind of thing, taking the square root of both sides to solve for x, you got to remember that there's a positive answer or a negative answer. You know, let me refer you back to like maybe a more basic example, like x squared equals 16. X squared, like what squared actually equals 16? Well, 4 squared equals 16, but so does negative 4. If x was negative 4, it would also be true. So kind of that's why. You know what I mean? So that's the answer. Right? And just, you know, to kind of elaborate a little more, full story. If you weren't able to actually solve this for x and get x by itself, you would try to factor, you know? And the factoring here, I mean, it might get you there, but, you know, the factoring here only gets you so far. But also remember that you could do the quadratic formula. You know what I mean? Where a would equal 4, b would equal, I guess, 0, and c would equal the 100. So this would also have been an option, the quadratic formula. Speaking of the quadratic formula, I wonder if that's how we are going to end up needing to do this one. Because check it out. It's pretty obvious from the start here that we are not going to be able to just get x by itself. So our next plan, stay with me here, we're almost done, please pay attention. Our next plan would be, well, maybe we can factor. You know? Maybe we can factor. Now, when I look at this, first I try a GCF, which, no, there is no GCF. But then you try unfoil. Now, looking at that 3, you know, the method of unfoil you would try would require the Phoenix method. Remember the Phoenix method? So let's give it a try. And let's. I don't know if it's going to work out, but there's no harm in trying. So we multiply the 3, the Phoenix, to the other end, and we get x squared minus 4x plus 18. Now, we try to unfoil the easy way. What two numbers multiply to get positive 18, but they add up to negative 4? Yeah, no, this is not gonna work out after all. Oh well. Right? No, don't feel bad about running into a dead end there, hey. So after that, oh man, this doesn't unfoil even by Phoenix method. Well, guess what? We still have the quadratic formula where a equals 3, b equals what? Negative 4, that's right. And c equals positive 6. So here we go. Opposite of b plus or minus square root of. So opposite, b is negative. Keep track of those negatives. Plus or minus square root of b squared minus 4ac all over 2a. Alright, we do have a negative b that you got to be very weary of. At least there's not a negative c value, but again, mind your negatives, keep track of your negatives. So a negative 4 is positive 4, plus or minus. Negative 4 squared is positive 16. And then a minus, and then, or, as I usually think of it as a negative 4. Negative 4 times 3 is negative 12. Times 6 should be negative 72, I do believe. And then 2 times 3 is 6. So 4 plus or minus 16 minus 72. Hey, I'm not ashamed. I'm going to grab a calculator. Not only that, I'm going to double check that negative 12 times 6 is negative 72. Again, I don't care. Don't judge me. But what I'm going to do next is, what the heck is 16 minus 72? I know there's some of you that, again, are judging me right now, but hey, I'm on the calculator. Negative 56. At least that's what the calculator says. Alright, check this out. Look what happened. We got a square root of a negative 56, a negative number. So last section, I made a big deal, or I tried to, about how you're not going to have any real answers. I'm going to write this again. So there's no real solutions. But there are some imaginary ones, because now we know that we can take out the negative, but we do have to have it as I. 4 plus or minus I root 56 all over 6. Now, I'm going to call it a day, but I'm just saying, I'm calling it a day as this is where I would expect you to get to before stopping. But I'm just saying, okay? I'm just saying the square root of 56 actually can simplify some more. I'm not going to be that strict on you right now, but I'm, again, just saying, square root of 56 does simplify, and then considering with the 6 down there and the whole thing considered, there's probably going to be a little bit more simplifying that even happens after you simplify the square root some more, but never mind. That's it.